Hey, this is Kenneth, and today I'm going to be talking to you about multiple input, multiple output, and its applications in digital communications. Multiple input, multiple output, or MIMO, is a system where one or many stations communicate to each other using multiple antennas. So for a simple example, when a single station wants to talk to a single station, traditionally it only uses one antenna and a single frequency. It modulates the data somehow, and it's received by the other channel. For an example, QPSK takes on the IQ domain one of four symbols, here, 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 or here, and makes them represent, for example, the bits 1 and 1, 1 and 0, 0 and 1, and 0, 0. The problem here is that when you start trying to move these symbols faster, the noise makes it so that when you try and shoot for this symbol, you actually end up someplace not quite there. And so statistically, the noise ends up occupying some space around it. When you then want to subdivide and put more symbols, for example 16 QAM, you need to increase the power of each symbol so that this bubble of noise doesn't overlap between one symbol and the next, because then you can't tell which symbol you're actually transmitting. This doesn't scale well. To get a single order improvement in symbol meaning, you need a order of magnitude increase in power. And so to get a 3 dB improvement in signal to noise, you need an order of magnitude more power improvement. In the 1990s, they realized that this could be improved by taking, instead of trying to improve the single link by turning the power up, instead improve the station-to-station link by having multiple antennas. When you have this array of antennas here, suddenly you're no longer talking about a single link, but you're talking about a link between each antenna. And you can then calculate the transfer function between the input x and the output y. The received signals on y are going to equal some noise of the environment around you plus this transfer matrix called the impulse response of the channel times the vector of your input of your transmitted symbols over here. The huge advantage is that even though each one of these signals, each one of these antennas is the same power, you gain the same amount of throughput on each one of them. And so suddenly the improvements gained by adding more antennas is linear, where adding more power to a single antenna was logarithmic. And this gives you lots of advantages. So for example, the link between this antenna and this antenna could be considered H11. Between here and here would be H12, and then H13. By being able to resolve this matrix somehow, and then applying it to your communication system, you can then take advantage of multiple inputs and multiple outputs to enjoy a better throughput on your entire system without having to increase your power in exceedingly beyond that which you started with. The disadvantage of this is that suddenly you need multiple antennas. For smaller devices like cell phones, this is problematic because the antennas need to be physically separated by a significant wavelength, a significant portion of wavelengths, to get you the physical diversity that the system depends on. In a cell phone, this can be problematic because suddenly you need to put antennas farther apart than the physical size of the entire cell phone. One place that you see MIMO used quite a bit is in contemporary 802.11n or 802.11ac Wi-Fi. 802.11 Wi-Fi operates on the 2.4 gigahertz band and the 5.8 gigahertz band. This works out to be just a dozen centimeters. So this is 12 centimeters here, and then it's half of that, so it's about 6 centimeters on the 5.8 gigahertz band, which means that since the wavelength is relatively short, it's easy to separate the two antennas on it significantly. For laptops, this is very trivial, since typically on a laptop, the two antennas are put on the opposite sides of the monitor, and that's plenty of separation for such a high frequency that Wi-Fi operates on. So this lets you in Wi-Fi operate multiple streams from inputs to outputs, which allows you to deal with fading between any two individual antennas. And so if H13 suddenly becomes 0 for some reason, and this input antenna can't talk to this output antenna, it's not a big deal, because you still have 8 other links between input antennas and output antennas that can still operate. So this has been Kenneth showing you what the basic concept of what MIMO is, and trying to explain how and why it is preferable to just trying to have a single radio link on which you turn up the power. Thanks for watching.